Hi folks, Harry Frank from Red Giant here, and in this lesson I'd like to go through some of the basics of Trapcode particular. We'll cover some frequently asked questions, cover some basic terminology, and then we'll cover the first two sections of the particular interface. And this will be a good starting point for us to start moving into some more advanced material. Okay, so that we're all on the same page, let's start at the beginning and create a new composition to work in Adobe After Effects. I'll create a comp that's 1280 by 720, 30 frames per second. I'll use a duration of 8 seconds, and the background color doesn't really matter, although I generally use black for any of my effects. Now, because Trapcode Particular is an effect that you will access through the Effect menu, we need something to apply it to. Generally what we do is apply this to a solid, which is created by going to Layer, New, Solid, or you can notice the quick key there, Command-Y or Control-Y in Windows. It's important to make this the size of the composition by clicking on Make Comp Size. And generally, you'll want to name this something that makes sense. Generally, I'll call this particular. Or if I'm doing something specific with this layer and using multiple layers, I'd call it what it might be, fog or pixie dust or whatever it is. So in this case, we'll just make some simple dust. So the first thing you'll see are the default settings in Trapcode Particular, which are a bunch of white spheres emitting from a single point in the center of the screen and moving outward. Now, before we get too far, let's do one more thing, which is add a camera to our composition. The reason I want to do this is Trapcode Particular is a 3D plugin. You can see this by the little icon next to the name of the effect. What this means is that the 3D space of the plugin, Trapcode Particular, and the 3D space of Adobe After Effects share the exact same coordinates. Now, this might sound pretty obvious, but what this means is that when a coordinate in particular is 640 and 360 and 0 in X, Y, and Z, that will directly correspond to 640, 360, and 0 in Z in Adobe After Effects. Now, the reason I say that is because this isn't true of all particle plugins. Some older plugins actually use a 0 to 1 coordinate system based on the size of the composition. And it can be pretty difficult sometimes to locate exact coordinates when you don't have matching coordinates between your 3D worlds. Now, while we're on the topic of 3D space in Adobe After Effects, let me talk about one of the frequently asked questions with Trapcode Particular. Now, this relates to layer order in Trapcode Particular. Let's say I add another layer that is a 3D layer, and I want these layers to interact. Now notice as I rotate the camera around that my particles and my text share the exact same space. This is great. But notice what's happening if I zoom in just a little bit here. If we look at the color of the text and the color of the particles, you'll notice that particles never go in front of the text. So even though the coordinates are exactly the same between Trapcode Particular and the 3D layers, they do not share what we call a unified 3D space. The 3D space of the 3D layers in After Effects and the 3D space of the effect on the layer are separated from each other. The 3D space of this After Effects layer and the 3D space of this effect, Trapcode Particular, do not actually interact with each other. So if I solo this layer and look at Particular, this 3D world is a world unto its own. It exists on this layer and it does not interact with any other layers. That's just how the rendering engine works in Adobe After Effects. Plugins do not have access to any sort of unified 3D space that interacts with other layers in the composition. So however I stack these in the comp is going to be how they interact with each other. Now, that said, later on in some more advanced lessons, we'll talk about the visibility section, which has something called an obscuration layer as well as a Z buffer. And this can be used to obscure particles and work around this shortcoming, but that's getting way ahead of ourselves. I just wanted to bring this up because this is one of the most frequently asked questions when people get started with Trapcode Particular, how to get particles to go in front of text. One more point I want to bring up is that notice when I created my solid and I added Trapcode Particular, I did not make this a 3D layer. My text is a 3D layer and this will rotate in 3D space. My particles are on a 2D layer, but they still work in 3D space, and that's how it should be. If I change this solid to a 3D layer, this is not going to work. Essentially what I'm doing is projecting the 3D space of particular onto a two-dimensional solid that is now rotating in 3D space. And essentially I'm applying my 3D transformations twice. You don't want to do this. In fact, I could say you would never ever do this, but there might be the rare occasion where you would actually want to do this. But 99.99% of the time, you are going to want to leave your particular layer a 2D layer. In other words, do not check the 3D checkbox. Leave it 2D, and that will work just fine. Now, let me delete this layer, and let's take a look at the Trapcode particular interface. Now, I think the key to learning and understanding the Trapcode particular interface is to compartmentalize your understanding of how it works. Now, what I mean by that is, as you can see, things are divided into sections. And I think you should really think about the plugin in terms of what the sections do. In other words, if I want to control a certain parameter, like how fast the particles are moving, what kind of gravity is affecting them, or what color the particles are. Each of those properties is associated with a certain section. So even if I don't have the whole interface memorized, which is quite difficult because there are a lot of parameters in particular, there are sections inside sections inside sections, and it gets quite deep. So you don't have to exactly memorize things, but you should understand what each section does. So when I want to adjust the velocity of a particle, how fast it's moving, I would go to the emitter section because there is a velocity control there, because I know that the emitter section controls where particles are born, what direction they're moving, and how fast they're moving. If I'd like to change the color of the particle, that's not a function of the emitter, it's a function of the particle itself. So I'd go to the particle section and change the color. But if I'd like to change gravity, that's a physical simulation. So I'd go to the physics section and look for gravity, and there it is, indeed, one of the first controls in the physics section. So as we learn more and more about Trapcode particular, you'll learn all the various functions, and you'll be able to associate each function with a specific section. I already spoke about the visibility section where we can obscure particles and make certain particles visible or invisible. And in general, what you'll find with Trapcode particular, as well as most other Trapcode plugins, is that the order in which things are calculated is presented in the interface top down. So we would start in the emitter section where the particles are actually created and what the points in space are where these particles should be. Then we define what the look of the particle is, and then we render particles at each of those points. And then we alter those particles in certain ways, either by shading options so that they will be illuminated by lights or have shadows. And then the physics section will change the direction of those particles as they're moving with gravity, turbulence, wind, that kind of thing. Then we can change the whole thing, transform the whole world system with the world transforms, and then we can start to actually obscure some of those rendered particles with the visibility section, and then we have rendering options that allow for depth of field and motion blur on the whole universe of Trapcode particular on this layer. So I always try to think of particular as a top-down interface, and I always think of what section I need to work with when I want to change a specific parameter. So let's take a quick look at the first two sections, the emitter section and the particle section, skipping over the register dialog because that's simply where you enter your serial number when you purchase particular. The emitter section controls how many particles we have, particles per second, where they are born, position X, Y, and Z, what direction they are moving when they are born, such as uniform or directional, and I'll cover those in a second, and how fast they are moving, which is controlled by both velocity randomness, and velocity from motion, which inherits velocity from the movement of the emitter itself. Now, with the emitter, it's important to think of it as the area in which particles are born rather than a specific point, because although the default setting is point, there are many other settings that we can use. Once I set this to box, we'll see three other settings open up down here, which allow us to set an area in which the particles will be born rather than a single point in space. So if I set this to box, we'll see that we have a cube that is 50 by 50 by 50 pixels. Now, the area in which we see particles is certainly not 50 by 50. It's actually a much larger area. And that is because the default velocity is 100. This is 100 pixels per second. So any particle that is born inside this 50 by 50 by 50 box can move in any direction from its point of birth at 100 pixels per second. And actually it's going to be 20% above and below 100 pixels per second because of the velocity random here. So if I zero this velocity so that particles do not move at all, we'll see this shape of this cube, and we'll be able to expand the size of this out. So I could expand it by x and y and by z. So it's a good way of making basic dust in After Effects, especially if you have camera data from another 3D application, or you're just working in After Effects and making some sort of motion graphics piece where you're drifting through space. Dust gives a good sense of 3D motion. Now, to make decent looking dust, we need a little bit of velocity on there. Fortunately, because of the default setting is uniform, this will behave a lot like dust, which is moving in random directions. So let's cover this direction setting. What's going on here? A setting of uniform in the direction setting means that particles, when they're born, are free to move in any direction 360 degrees all the way around the particle, up, down, left, right, back, and forth. So what do the other settings do? In fact, let me pull up some other comps. A directional setting gives particles a specific direction that we can control with this emitter angle. There's also a direction spread. So you can see this is good for fire or perhaps a water hose or anything that needs a very specific direction. Bidirectional is very similar. It just shoots in two different directions at the same time. So if I were to animate the rotation of the emitter over time, we can see we can get this kind of spiral shape. A disk is somewhat random like the default setting, but it only emits in 2 dimensions. Now the direction spread in this case, if I angle myself into the side, we can see a setting of 0 and the directional spread flattens out the disk, and as I increase the directional spread, they will spread into that 3rd dimension. Now, a setting of outwards is a little more conceptual. It's very similar to uniform with one critical difference. Although they are all moving randomly, notice that they all move away from the center point of the emitter. And this is exactly what outwards means, is that they will always move away from the center. Their random angle will never be toward the center. Now, in terms of the emitter type, I've basically spoken about point and box. Sphere is basically the same thing as a box, except that instead of a cubic area, it is a spherical area, and these are still controlled by the x, y, and z coordinates right here. So if I set this to 500 by 500 by 500, I should see a fairly spherical area in which the particles are born. So what are some of the other options we have in here? Let me jump to a different composition. When I'm using a point, notice that my parameters are divided into x, y, and z. You may be asking why these are separated into x, y, and z. Well, it's kind of a legacy issue. There was a time when Particular was developed where we simply did not have a 3D point control. It just didn't exist, and that's how Particular was developed. But there's an easy workaround, and one of these is to use a light emitter. So if I go to Layer, New, Light, I'll set the light name to the word emitter, and I can use point, but in this case I'm going to use a spotlight. Let's move this away from the camera a little bit. Let's open up my light options by hitting AA, and I'm going to make the cone angle a little bit more narrow, and let's point the point of interest upward just a little bit. There. So if I go to my emitter type and set this to lights, what this is going to do is use the light position to control the 3D position of my particles, which is pretty cool. This makes locating in 3D space much easier. Now in the case of using a directional emitter, the cone angle will control the directional spread. Notice when I set this to directional lights, directional spread is grayed out. This also works for bidirectional. And I can also set this simply to a point light and eliminate the direction spread entirely. Now, wrapping up the emitter types here, we've got a grid emitter, which basically emits particles on a 3D grid. When we enable the grid emitter, we are able to access the grid emitter options down here, and you can see that we have 5 by 5 in X and 1 particle in Y. I could set this to, let's say, 3 by 3 by 3, and I will have a 3D grid, and the particles emit from points on that grid. Now that covers the first 5 options. The last 2 options allow us to use 3D layers in After Effects to emit in 3D space. Now, I'll cover that in a later example because that's getting a bit ahead of ourselves. Let's stick with a basic box setting here, create some simple dust for After Effects. So I'll expand out this area and close up the emitter section. So let's say we're making dust. I think we're pretty close here. Maybe we have too many particles, so I'll go to the emitter section, lower this to 500. The only thing I think I need to change at this point, I think, is the look of the particle. If we watch closely, we'll see particles sort of popping on and off. And this isn't ideal. Dust doesn't do that. They don't simply disappear and reappear. So under the particle section, this is where we control the look of the particles. The size, the opacity, the color, and the shape of the particle are all controlled in the particle section. There's also rotation controls for particles that actually have some sort of visible change when they rotate. In this case, we're just going to use a sphere. I'm going to lower the size. This is the size in pixels. And then I'll adjust the size randomness so that they're not all the same uniform size, which would not be realistic. I can also randomize the opacity, and I'm going to randomize the lifespan of the particle. Now, a color of white is going to be just fine. Maybe you want to add a little bit of color randomness in here. But more importantly is the issue where the particles appear and disappear. We have 2 options to take care of this. We have a size over life option or an opacity over life option. If I take a look at this, I can simply draw a chart in here that charts the size over the lifespan of the particle. So over 3 seconds, the particle will be born. It will have a size of 0. It will size up, and then about a quarter of the way through its life cycle, it will go down to its death. So for easy math, I could set this to 4 seconds. We would basically have a 1 second fade on, 2 second lifespan, and then 1 second fade out. There's some preset shapes over here that you can click on and just pull up automatically. We can also randomize it, and we can also smooth out any jagged edges on the graph. You can copy and paste between these graphs using the copy and paste buttons. In terms of size over life, I'm simply going to leave this as a flat line, and then down here I'll have the opacity fade up and fade down over 1 second at the beginning and end of the lifespan. It's looking pretty good. Now, one last thing I'm going to do is go to the camera itself under camera options and turn on depth of field. Let's turn up the aperture and I crank up the blur level to kind of exaggerate this. Now, although this is a bit of an advanced option in particular, which is all the way down here at the bottom where we have depth of field, the default settings are to use the camera settings. So whatever I set the camera to at this point is going to control how the depth of field renders in Trapcode particular. So if I set it to a very blurry, high aperture setting, that's the kind of setting that we're going to see in my particle settings, which is often very good for dust because it would often be very out of focus close to the camera. So that isn't everything in the first 2 sections, but I wanted to keep this a short overview of the emitter and particle sections just to get you started. We also covered some of the frequently asked questions and just gone through the basic terminology of how to get started with Trapcode particular. So in later lessons, we'll get into much more complicated material and setting up specific projects that use emitter and particle options. So I'll see you in the next tutorial.